right, good times. Limit as theta goes to 0 of sine of theta over theta. Do you remember what that is from yesterday? Find it. Flip, flip, flip. Find it. What we learned yesterday is that is 1. If you flip it upside down and have the limit as theta goes 0 of theta over sine of theta, it is still 1. You also learned yesterday that the limit as theta goes 0 of cosine of theta over theta is 0. Now, this can take different forms. You can have 1 minus cosine of theta over theta is also equal to 0. You could have the limit as theta goes to 0 of theta over cosine of theta minus 1 is also equal to 0. So, if you take the reciprocal, you still get 0 in those situations. But, those are some limits that we need to commit to memory. And why are those things true? How do we know? Sandwich theorem. We proved that yesterday. Okay, that was a good time. So, this lesson did not go very well second hour. All we want to do is get through these 4 examples, but you gotta dig deep here. Okay, you gotta focus, and a lot of this has to do with that our might as well just give up. Let's not even do it anyway. The fact is that we struggle with fractions. So I'm going to put some things on the board here. We're going to see if we can understand this. I got the number 24 over 18. Everybody okay with that? Is that the same as 6 times 4 over 3 times 6? Yes. Good. Is that the same thing as 6 over 3 times 4 over 6? Yep. Is that the same as 6 over 6 times 4 over 3? Is that the same thing as 6 times 4 over 3 times 6 times 2 over 2? Yep. Is that the same thing as 6 over 2 times 2 over 3 times 4 over 6? Okay, so all we're doing is we are just using the commutative property of multiplication. And that's completely legal. And to be able to multiply by 2 over 2 is the same thing as multiplying by 1. You have to keep those rules in mind as we do these problems. Now, as you look at this, it says limit as theta goes to 0 of sine of 2 theta over theta. So this is just slightly different, okay? And here's what we know. If you have the limit as, I'm going to call it u goes to 0, sine of u over u is equal to 1. What that means is it doesn't matter what the angle is, as long as the same angle is in the denominator, then the limit is 1. Well, these angles are not the same, are they? What would I need in the denominator? So what I'm going to do is this. I'm going to rewrite this as the limit as theta goes to 0 of sine of 2 theta over theta, and I'm going to multiply by 2 over 2. You okay with that? Limit as theta goes to 0. Now, I'm going to put this 2 over by the theta. So what do I have left then if I put that 2 over there? I have 2 over, yeah. I don't want it. Isn't this just 2 times 1? I just put the 2 over there, just like we did in the examples I showed you earlier. Just brought the 2 over. Do I now have sine of an angle divided by the same angle? What is that? 1 times 2 is 2. What? Okay, this one, the limit as theta goes to 0 of sine of 3 theta over 5 theta. Now, I don't like the fact that I've got a 5 theta in the denominator. I can't do anything to this 3 theta. It's tied in with the sine. It's sine of. Okay? I can't move that 3 around, taking the sine of that. I would have to do sine inverse first. But I can play around this 5 theta, okay? So instead of a 5 theta, I would rather have a 3 theta, right? So I'm going to multiply top and bottom by 3. Not 3/5, because 3/5 is 3/5. I'm multiplying by 1. I'm allowed to multiply by 1. So I get the limit as theta goes to 0 of, I would like to put the 3 over here and the 5 over there. Can I do that? Because multiplication is commutative. Sine of 3 theta over 3 theta times 3 over 5. What is sine of 3 theta over 3 theta as theta goes to 0? 1 times 3/5, 3/5. Now, something important that, go ahead, Brody. Most of the time it is. Most of the time it is. Not all the time. Okay. And I want to be clear, sometimes you'll come up with the right answer, but your work won't be correct. I will be judging your work on the test. Okay, so I need to see you have the correct work. Now, it's nice to be able to look and say, I think I'm probably supposed to come up with 3/5, but make sure your work verifies that. I want to show you real quick. If I plug in 0, what is the sine of 0? 0, very good. Divided by 0, we get 0 over 0. That's why we don't know what this limit is, and we have to kind of do some crazy stuff with it. Same thing here. Sine of 0 divided by 0. Yeah, so let's check here. If you don't get 0 over 0, then what if you got 0 over 2? What's 0 over 2? So then the answer would be 0. We don't know what 0 over 0 is. What's the cosine of 0? 1 minus 1, sine of 0. Okay, so we still end up with that situation. Oh man, what do we do here? Cosine of theta minus 1 over sine of theta. Well, I wish instead of the sine of theta in the denominator, I had what instead? Just theta. Like if I had just a theta down here, that'd be great, right? Let's multiply by theta over theta. What's theta over theta? It's 1. So now I've got cosine of theta minus 1 over theta. So I used up this theta. That's gone. I used up the cosine times what's left. Theta over sine of theta. Well, hey, I know what this limit is. What's this limit? 0. I know what this limit is. And 0 times 1 is, hey, so I just crossed it off because I used it up. So my cosine of theta minus 1 over theta is right here. And then my theta over my sine of theta is right here. The limit as theta goes to 0 of theta over sine of theta is 1. We have that right here. Go get some food. Brenda's birthday. What a great day. All right, here we go. Last example. This one's got tangent in it. We haven't seen an example with tangents. So what do we do? You just want to cross off the tangents? I crossed off this problem. I don't want that problem. I'm making a new problem. For Maddie, 1, 2, 3. They're just a variable. Now what? Multiply by the reciprocal. Huh. You know, I don't see anything up above that really has a cosine in it unless it's got a cosine minus 1. We don't have that, do we? But, so let's focus on what we do know. We have a sine of 5x, so what do I want in this denominator? I want a 5x, right? So I'm going to multiply the top and bottom by a 5x. And then as I look at this second part, I have a sine of 2x in the denominator. What would I like to have in the numerator? Just a 2x. Let's see if that helps me out. So I'm going to go sine of 5x over what? 5x. I like that. I know what to do there. Well, I'm just moving it. I'm just using the commutative property of multiplication. The cosine will just take one of those spots. But it's cosine of 5x. We can't just like take that cosine out. I don't want to do cosine of 2x over 2x. I want to do 2x over sine of x, 2x. So I used up the sine of 2x, and I used up the 2x. So it looks like I've got some things left over. I've got a cosine of 2x over a cosine of 5x. And then, can somebody tell me what 5x divided by 2x is? It's 5 halves, right? The x's cancel. Don't worry if you said 3x. That's what all of second hour said as well. Right? 5x divided by 2x, the x's cancel, leaves you with 5 halves, right? So, now I know that this cosine of 2x over cosine of 5x bothers you, but don't worry, it doesn't need to. Limit as x goes to 0 of sine of 5x over 5x will be? Limit as x goes to 0 of 2x over sine of 2x is? Let's plug in 0. What's 2 times 0? What's the cosine of 0? 1. 5 times 0 is 0. Cosine of 0 is 1 over 1 is? Oh, so these really weren't an issue, were they? So remember in the unit circle, and we're going to review this tomorrow, that what is that coordinate right there in the unit circle? It is 1, 0. Is cosine the x value or the y value? Cosine is the x, sine is the y. So the sine of 0 is 0, the cosine of 0 is 1. Okay? And so when we plug in 0 for cosine, it's really not an issue. It's just when we do it for sine. So there's your answer, 5/2. I have a worksheet for you to do. And it's not a packet. There is no staple.